Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonyola Olo and I've been walking you through the physics course. In this class we'll be talking about, in this lesson we'll be considering electrical fields, capacitors and capacitance. And we'll be considering the topics capacitors. We'll look at what capacitance is, and we'll examine how to calculate the energy stored in a capacitor. Okay, what is a capacitor? From general knowledge and from what most of people would think of, I always like telling people that most of the things that we call our batteries today are capacitors. A capacitor is an electric device which is used to store electrical current, electrical charges in summary. Although capacitors find more applications in electronics, but basically that is what they are used for, storing of charges. It contains a system in which you have two electrical conductors which carry charges but are separated by an insulator. When a battery is connected to a capacitor, the battery will be run down. That is, the battery will be drained by the capacitor as the capacitor will be charging off the source of electricity. But when there is no more electricity for the capacitor to absorb energy from, it stays on its own and it retains its charge until another thing is placed on it, something that demands the use of electrical charges, and it discharges this charge which it has stored into that source. If we think deeply, we'll see that that is exactly what our phone batteries and other batteries, our rechargeable batteries, that is what they do. We can charge them and we can use them up. The using up is known as discharging. So, having spoken about capacitors, some questions will pop up on your screen to test your knowledge of what has been taught in this lesson so far. Welcome back. We've talked about capacitors and we've described them as an electrical device for storing charge. So, what is capacitance? The capacitance of a capacitor is the ability of the capacitor to store charge. The capacitance of a capacitor is the ability of the capacitor to store charges. So it is what gives the capacitor the power to store charges, and it is dependent on a couple of features, such as the distance between the plates, that's the conductors. It's also determined by the nature of the conductors, the nature of the insulator between them, and also it's dependent on the arrangement of the circuit, the size of all of this, each of these components, the surface area of the conductors, the thickness of the insulator. Well, let's work with capacitance. Let's do some capacitance calculation. It is possible for you to connect your capacitors in series, just like when we were working with resistors. It's possible to connect your capacitors in series, and it's also possible to connect your capacitors in parallel. When you connect your capacitors in series, capacitors are represented with the symbol, two lines, the same height, unlike our cells, which have one long line and one shorter line. Here we have two lines that are the same height. So if you connect your capacitors in series, how do we find the total capacitance? C1, C2, C3. When capacitors are connected in series, total capacitance equals to 1 over C, which is total capacitance, 1 over C1 plus 1 over C2 plus 1 over C3 in series connection. That's in series connection. In parallel connection, Of course, that looks very different. It is simply calculated as CT equals C1 plus C2 plus C3, where this is C1 and this is C2 and this is C3. You simply add their numerical values. So we have a question here. The question says we should look at the diagram and we should calculate total capacitance of the circuit. Okay. By what we were taught, the easiest way to do it, of course, you first add your parallel connection so that everything can be in series. So your parallel connection, how do you add? You just add the numbers. That's 4 plus 4 will give me 8. So the whole of this place becomes 8 microfarad. Now, the whole of this section becomes 8 microfarad. Yes, it is very good for you to know that capacitance is always measured in farads. It could be microfarad, it could be nanofarad, it could be picofarad, but it is always measured in farads. It could be millifarad on some occasions. The pico or milli are all sub-multiples. So let's proceed. After knowing that, we can now calculate for everything on the series connection. Working with series formula, we'll have to say 1 over CT equals 1 over 2 plus 1 over 2 plus 1 over 8 plus 1 over 3. LCM would be 24. That's 12 plus 12 plus 3 plus 8 equals 1 over CT. So our 1 over CT will be equal to 24 plus 11, that's 35 over 24. So CT would be 24 divided by 35. That's CT. So we've gotten our first answer, 24 over 35 microfarad. Okay, let's take a question. We have this question. They give us this particular diagram and we have to calculate the total capacitance in the circuit, energy stored in the circuit, and charge stored in the 3 microfarad capacitor. And that's very good for me to remind you. The unit of capacitance is farad. And it can be microfarad, it can be picofarad, it can be femtofarad, it can be kilofarad, it can be microfarad, it can even be millifarad. But farad, that's the unit of capacitance. So, of course, the easiest way to start is to start with the parallel connection. We first solve out our parallel connection. That's what we have here. And from our formula, we're taught that parallel connection, you just add the values involved. That's 4 plus 4 will give us 8 microfarad. So we have 8 microfarad for that. Then we can start solving the parallel the series connection. To solve our series connection is solved using 1 over CT equals to 1 over C1 plus 1 over C2 plus 1 over C3. In this our case, plus 1 over C4. So we can do 1 over CT equals, that's 1 over 2 plus 1 over 2 plus 1 over 8 plus 1 over 3. That means we'll have to find LCM, which is 24. 2 in 24 is 12. 12 times 1 is 12 plus 12 again. This time around will be 3 and then 8. So 1 over CT will be equal to 35 over 24. and our CT would be the reciprocal, which is 24 over 25, over 35 microfarad. So that's our answer. So the entire expression equals 24 over 35 microfarad. Let's keep that for our next question. Next question requires us to find the energy stored in the system. Of course, we're given the voltage to be 40 volts. So we already have our capacitance. We know that energy stored or work done equals to half CV squared. And that is, in this case, half. Our C is 24 over 35 times 10 raised to the power of minus 6, that's micro, multiplied by 40 squared. When we calculate this on our calculator, so our answer is equal to 0.000549 joules. That can also be said to be 549 microjoules. So we can keep that as well. To calculate the charge across this particular capacitor, that's 3 microfarad. Well, the capacitance, we all know that when it comes to the way capacitance work, it works, calculate the charge, not capacitance now, charge across this that particular place. We know that the way current works, current is constant in a series connection, and charge is current is simply a charge that is moving. So the amount of charge that will be here is the amount of charge, total charge that will be supplied to this, and is the amount of charge that will be here and the amount of charge that will be here. So to calculate the amount of charge, we can simply say charge equals to total capacitance multiplied by the velocity, by the voltage. So that will give us total capacitance is calculated to be multiplied by the voltage, which is 40 volts. Using our calculator, we would get 27.4 microcoulombs. Our charge is measured in coulombs. So, having looked through the topic on electrical fields, capacitors and conductance, and we looked at capacitors, we explained what a capacitor is. We defined a capacitor as an electrical device, an electrical implement, an electrical device that stores electrical charges. We also discussed capacitance of a capacitor, and we said the capacitance of a capacitor is the ability of a capacitor to store charges. We then looked at energy stored in capacitors, since everything we have been talking about is all about storing charges. So we calculated energy stored as work done equals half C V squared, where C is the capacitance of the capacitor and V is the voltage. Work done is also calculated by half QV, where Q is the charge in a capacitor. We also can calculate the charge of a capacitor, charge accumulated in a capacitor, by VC. In a few seconds, some questions will be displayed on your screen. Please attempt them. And if there is anything you do not understand in what has been taught, you may view the video one more time. Thank you.